the problem looks like this. So we have few points on x-axis and the corresponding values on the y-axis, right? In the regression solution looks like this. How do we measure a regression solution? We will study today the evaluation, but regression in detail we will be studying soon in the upcoming module. So the key idea behind evaluating a regression solution, this red line is the regression solution. The key idea is to measure the distance between actual data points are these black data points. And your prediction is where? For every data point, your prediction is on the red line. So if do you see some squares, red squares?
Yes.
So we take the distance between prediction on the red line, which is our model, and the actual value. We take the distance and square it. You see these squares, right? The red squares. These are the errors of model. If we add these squares, we are going to call them sum of squared errors. So regression is evaluated using numbers like sum of squared errors. So you can visually see what is sum of squared error is. SSE. You can take the root of SSE, it becomes RMSE. Root means of squared errors, but this is what a squared error looks like. You have a model, the red line is the model. You're trying to predict, given the value on X, what will be the value for Y? Y is our dependent variable.
Okay.
What is our independent variable?
It's X.
X. So independent variable and dependent variable have these values. We have 5 points, and based on these points, we train or we learn a model. This red line is the regression model that we can use to predict, given a value X, what will be the value for Y. So for 10, the value will be?
It's 0.
0. For 40?
40, it is 20.
Around 20, right?
Yeah.
So given a value for independent variables, we predict the value for dependent variable. In case of classification problem, the dependent variable was categorical. We said red, blue, male, female, crime, no crime, fraud, no fraud, will buy, will not buy, will stay, will not stay, classification. But now we are dealing with a dependent variable where values are continuous. When the dependent variable is having continuous values, we do what?
It's regression.
Regression. We do regression, right? So when the dependent variable is continuous variable, then we do regression. Now we want to evaluate a regression solution. For that, what do? So we look at sum of squared errors. The prediction and the actual value, we take the difference and we square it. You can see the square boxes, red boxes, right? These boxes, if we add them up, it will become a big box of errors. We call it sum of squared errors, or SSE. So now you can see here, when we sum these boxes, the SSE for this particular model is 832.69. Okay. For classification, confusion matrix. For regression, squared errors. Just 2 things that you need to remember for today, okay? So the red line that you see here is the regression model for these points. And it has 2 parameters. One is this one, you see, minus 9.75. And the second parameter is this one, 0.68. Okay.